Hello and welcome to Technical Utkranti. And with this video, we'll be starting a new section in DSA series, which is recursion. So in this video, we'll be only looking into understanding recursion from its very basics and will not be looking into solving any question. So let's get started. But before that, let's have a look at the thought for the day. So with a smile, let's start to understand a recursion. So these are the topics that we'll be looking into this video. Defining recursion. So first of all, understand what is recursion, then why we need recursion, how recursion works, then we'll see its comparison with iteration, and when to use and avoid a recursion, and then at the end how to write recursion in 3 steps. So recursion is the way of solving a problem by having a function call itself. Okay, for example, consider a function representing the action of bowling in cricket. So the cricket example might be relatable to all. So let's understand it with it. So this is going to be the output of the function. All right. As you can see, I have solved this problem by having the function call itself with different inputs. And at one particular input, I say that, okay, now just end the recursion. And that's it. So there are two main points to look into this, that performing the same activity multiple times with different inputs as we are doing. So we are calling the same function with different inputs and a base condition needed to stop the recursion. Otherwise, there would be infinite loop. So if n equals to 7, this condition check was not there, then this recursive call would go on for infinity and will not stop. Okay. So I hope you got a little bit taste of recursion. Now let's see, why do we need recursion? So firstly, you have to accept that recursion is an intuitive topic. When more sophisticated problem comes up, you cannot directly think how to apply recursion in it. But the proficiency comes with practicing questions. Recursive logic is relatively easy to write as compared to iterative logic. So, recursion doesn't involve writing a loop, but iterative logic has for loop or while loop in it. So, developing recursive way of thinking about the solution of the problem is important because writing and reading the recursive logic is relatively easier. So often recursion can be replaced with iteration. So whatever logic that you are writing with recursion, most of the cases, the same logic could be implemented using iteration, right? Recursion is prominently used in data structures like trees and graphs. And like there are some algorithms like divide and conquer algorithm, greedy algorithms that we have seen in the previous videos of the series, and dynamic programming. Here the recursion is heavily used, right? So these are the points which highlight the significance of recursion. Let's move ahead. Now, this is a very important step in understanding recursion, that how does it work. So I have two code snippets over here. What I've done in these two snippets, so this snippet and this output we have already seen, all right? But as soon as I move this print instruction after this particular instruction, the output is totally reversed, right? So as you can see, whatever is over here was printed at the last, but whatever is here now is printed first, and then 6 5 4 3 2 1, which is reverse of the disorder, right? Why is it like that? This happens because recursion involves stack. Okay, so let's understand it. So firstly, we'll see the first example, right, where the printing was happening in order 1 2 3 4 5 6, like that. So what will happen is, when this bowling function is called, what will happen is it will check if n is equal to 7. So firstly it is 1, 1 is not equal to 7, then print will be executed. So this print will be executed over here. And then bowling of 2 would be called. So bowling of 1 would go on stack, which means that bowling 1 is still not finished, but bowling 2 is called, right? So the instance of bowling that is still not finished would go on stack. All right. Then while executing bowling of 2, it will come here and again print will be executed. Then bowling 3 would be called and bowling of 2 would go on stack, as you can see over here. Similarly, for 3 it will happen, for 4 also it will happen, for 5 also it will happen, for 6 also it will be happening like this. And when bowling of 6 goes on to the stack, then bowling of 7 is getting executed, right? So here this if condition would be true, and then this print command would be executed. So this is printed, the over is finished, and then return is encountered. As soon as return is encountered, last entry on the stack, so this will be popped out. Bowling of 6 will pop out, and there's no instruction over here, right? When bowling of 6 is popped out, the command flow comes here and there is nothing to execute. So the next pop is executed. So bowling of 5 comes out of stack, nothing to execute. Bowling 4 comes out of stack, again nothing to execute. 3 comes out of stack, 2 comes out of stack, 1 comes out of stack. So this example is easy to understand. Let's move on to the example where the printing was happening in reverse order. So what is the difference between this code snippet and previous one? The print is executed after the recursive call. All right. So here, when the return was executed, the popping of the function will result in code flow reaching to this print statement. All right. So in the previous code snippet, nothing was happening with the popping of the stack, but with this code snippet, there is one instruction that will be executed after each pop out from the stack. So let's understand it step by step. What will happen is for n equal to 1, the directly recursive call would be executed, right? Because there is no print statement over here for n equal to 1. So bowling of 1 would go on stack. Then for bowling of 2, again nothing to execute, straightforward recursive call would be there. So bowling of 2 would go on stack. Then bowling of 3 is executed, bowling of 3 goes on stack. 4 is executed, 4 goes on stack. Bowling of 5 executed, 5 goes on stack. Bowling of 6 executed, 6 goes on stack. And then bowling of 7 is executed. When bowling of 7 is executed, this if condition is set to true. And then this print happened. All right. So this printing will happen. And then the return instruction is encountered. As soon as return instruction is encountered, the last entry from the stack would be popped out. So bowling of 6 will be popped out and the code flow will reach over this print instruction. All right. Because the code flow would reach just after the recursive call, right? There is one instruction. So here n is equal to 6, right? So this will be printed. Now no other instruction is there. So this will be popped out. Bowling of 5 would be popped out. And as soon as it pops out, again the instruction flow reaches here and this will be printed out. Bowling 4 will be popped out. This will be printed out. Bowling of 3 will be popped out. This will be printed out. Bowling of 2 will be popped out. This will be printed out. 1, this will be printed out. And then nothing is on the stack. And that is it. So I hope you understood what difference did it make by just having one print instruction, by just having one print instruction after the recursive call as compared to having it before the recursive call. You understood the effect of stack, the effect of last in first out nature of stack on the output of the program, and you understood the involvement of stack with the recursive call, right? All right. So I believe that this particular logic, this particular concept is clear in your head now. Now let's compare recursion with iteration. So in recursion, we don't have any while loop, we don't have any for loop, because that is taken care by the recursive call itself. But in iteration, we don't have a recursive call, rather we have an iterative loop over here. So in much more sophisticated questions, the for loop writing or the while loop writing by the user involves more thinking, whereas in the recursive call, the code is easy to write and easy to read. That is just one benefit of recursion. All right. So recursive code is easier to read as compared to iterative code. That I've already told you. But the downside is much bigger. So the downside is that it is recursion is more memory and time consuming as compared to iterative code. Why? Because we have seen that recursive code involves stack memory, and push and pop from that memory. So this involves extra memory, and push and pop involves more time. That's why recursion has this downside. So when to use recursion? We saw that iterative code is better in both time and space considerations than recursive code. So recursion can be used when space and time considerations are not important. Correct? It can be used when we just need a quick working solution instead of an efficient one. Where can we use it further? So, as I've mentioned earlier, also it can be used in trees and graphs data structure. It is heavily used over there, and in dynamic programming algorithms. Where not to use recursion? So, for example, mobile applications which are designed to work even on low memory devices, there recursion shouldn't be used. For time critical applications, for example, airbags in the car, which which needs to function very fastly, their recursion should not be used, right? So let's understand the final part of recursion, which is three steps to writing recursion. Recursion has three main things. First is the recursive case, the case which creates recursion, the case where looping is involved. For example, in the bowling example, if n is not equal to 7, then this part of code is leading to recursion, right? I can also write it under else. So this part is a recursive case, all right? Then there's a base case. What is the base case? It is a terminating condition of recursion. So these three lines is the base case of this function, where n equal to 7 results in end of the recursion. All right. Without the presence of base case, the recursion will go on for infinity. And then finally, there's an unintentional case. So a function is not designed to handle negative inputs, right? So for such a case, we need to have something like assertion, where if the invalid input is provided by the user, that is filtered out. All right. So I hope you understood the recursion, and if you did, please give it a thumbs up and subscribe to my channel. Again, I'll repeat that recursion is one such thing which requires a lot of practice. Practice is required in everything, but recursion specifically requires a lot of practice to master it. So just go through as many questions as possible, and yeah, hopefully you would get better at it.